Hi guys, coming back at you from school. Hope things are going well. If you can tell, I'm recording these back to back from the last one. Missing you guys in class. So today's lesson is going to be on lesson 3.6, proportional and non-proportional relationships. When you're thinking about a proportion, it's comparing two different things. So when you're talking about a relationship, it's when you're comparing those two things and you see how they work together. I'm really distracted by Einstein, who is creeping behind me. I don't know if any of you guys have been noticing in any of my videos, but I just got real distracted by that. So I'm just gonna reposition myself here to not be distracted by that. Anyways, short lesson, should be pretty straightforward. I like this lesson as well because it's more story problems, application problems type of thing. So I'm going to jump right into it. This is in your study guide and intervention worksheet. I'm going to move myself over maybe here. So we're going to talk about natural gas, talking about in therms. That's pretty relevant to hear because a lot of us at least, burn gas when we're talking about keeping our houses warm. So it's talking about the total amount the gas company will charge for natural gas use and how it's based on how much natural gas a household uses. So it's talking about the natural gas use and the total cost. So it says to graph the data, and it's wondering what we could deduce from this. So if we use 1 gallon of gas, it says it costs $1.30. So at 1, we're going to go up and maybe a little past a quarter, about $1.30. After 2 gallons, it's about $2.60, so getting close to $3. At 3 gallons, I'm looking here now, it says that it was $3.90, so 3, pretty close to 4, but not quite. Then at 4 gallons, it's $5.20, so just a little bit past $5. So this is talking about the relationship between gas used and your total cost. So you can draw your line kind of from here. It's not the most perfect line, but hopefully yours looks better than mine. It's important to note here that at 0, obviously it's 0, 0, because if you use 0 gallons of gas, you have paid $0. And then we want to write an equation to describe this relationship. I want you to answer the what can you deduce from the pattern about the relationship and the total cost. So what they're looking for there is, how much are you paying per gas used in therms? I wanted to say gallons, but it's in therms. So like, how much are you exactly paying each time you increase? Then to write an equation, we don't have an intercept that changes, so we can just use the format y equals mx. Y being our cost and x being your gas used. That's just our general format we've worked on in earlier chapters. So our m is how much we're changing each time. Well, if we're talking about cost is y, and the cost is actually $1.30. And that's over your x value, or how much you're increasing by x, which is your gas used, and that's 1. So 130 over 1 times x, or just x, and that is your equation right there. Then it says to use this equation to predict how much it'll cost if the household uses 40 therms. So in our y equals 130 times the number of therms. Here my x equals 40. So you're just going to plug in 40 for x. This one might be a calculator kind of problem. If you want to do this by hand, you are more than welcome to. I am not, because it is the evening and I do not trust myself. But if you want to, that is more than all right. So you do 130 in your calculator times 40, or do it in your head, and it is $520. Nope, not 520. I forgot my decimal. $52. That makes way more sense. So that's actually a really good example. I'm leaving this in my video because I think it's important to see. I got to $520 and I thought to myself, that does not make any sense. When you get an answer, think about it in context of whatever problem it is. Does $520 make sense as the answer? I would probably say probably not. If it's like a little over $1 per gallon, that doesn't really make sense. So y equals 52. So the cost, remember word problems, we answer in words. So the cost is $52. So 52 bucks. And that is your final answer right there. I'm going to switch to the next one, so pause me if you need to finish copying this down. So then it says write an equation for the function notation and then complete the table. Well, you could do it in either order. For me, I would rather complete the table first, but you know, that's just me. So if we're talking about going from -2 to 2, and then from 2 to 6, it looks like we're adding 4 each time. I want to figure out that pattern. So here I'm adding 4 each time, so if I were to add 4 again from 6, this is kind of like our arithmetic sequence, it would be 10. 10 plus 4 gets me to 14. 14 plus 4 gets me to 18. Then we need to write an equation. So I want to know, remember with your slope is always the change. This delta symbol means change in y over your change in x. I already figured out what my change in y is. It's 4 because we're adding 4 each time. Then I need my change in x. Well, looks like we're changing by 1 each time. So my slope, or my m, is 4 over 1. That's how we get our slope. Then, if I can make this look okay, then we need to finish writing our equation. If I want to use y equals mx plus b form, I kind of want to know what my y-intercept is. My y-intercept is where x is 0. The nice thing about this table is I don't even have to figure that out. I have where x equals 0 right here. So my y-intercept is 2. So my b value is 2. These are some fun colors. Anyways, then we are going to put this in y equals mx plus b form. I'm going to leave y and I'm going to leave x. I'm going to plug in for m and b. That way I have an equation for any spot on the graph. I want y and x to be able to change, whereas slope is static. The slope doesn't change. It wouldn't be linear if the slope changed. So all I did was I replaced m with 4 and b with 2, just like we've done in the previous lessons. And that's how you do those problems. Pause this video and try the next one, and then we're going to move on. So the other way you might need to write an equation is in function notation for each relation. I will remind you that y could also be written as f of x. This is not f times x, this is f of x. That's how you read that. So they're interchangeable. You can write either, but in this case they want you to do it in function notation, and f of x is function notation. So first thing, I want to find my slope and my intercept, and I can do that actually just from looking at this graph. First thing I'm going to do is I want my y-intercept. This right here is your y-axis. That is the least straight line I've ever drawn in a while. And I want to check out, where do we cross the y-axis? I'm going to count these. Someone called them tiles earlier. These boxes are tiles, and it looks like we go 2 up. So our b, or our intercept, is 2. That's where we cross the y-axis. The m is your slope. I remind you, the m is change in y over change in x, or your rise or fall over your run. Looks to me like we're falling 1, running 1 to get from each spot, so it's just simply 1 over 1 or 1. You could write it as either. then you'll put it in y equals mx plus b form. Equals mx plus b. And then the last step is it says to put it in function notation. So instead of y, we will say f of x is 1x plus 2. Imagine f of x and y. F of x is like a nickname. You have, some people have their regular names, but they go by a different name, and it's their nickname. And so y and f of x, you would answer to your nickname and your regular name. Y and f of x both work, but f of x is helpful in specific situations, whereas, you'd pick and choose sometimes what nickname you'll use when. Kind of the same thing. Go ahead and pause it, try 5. I'm going to move on from that. Actually, just kidding. We're done. I thought I had more, but I'm going to stop here and not keep talking. Thank you guys for watching this. Thank you for trying to help yourself learn, and I appreciate that you have taken the time to watch this before coming to me with questions. I hope this goes okay for you, and the concepts are starting to make sense. All right, see you guys.